Hello and welcome to I&E's, the CCNP Candidate's Guide to OSPF. My name is Travis Bonfili and I'm going to be your instructor throughout this series. To tell you a little bit about myself, I'm a Cisco Certified Networking Academy instructor. I'm also a Cisco Networking Academy Certified Instructor Trainer, which is where I actually train instructors who are going to be going on to teach the Networking Academy curriculum. I hold my CCNP in routing and switching as well as wireless, and I am CWNE, or Certified Wireless Networking Expert, number 131. All right, so let's go ahead and dive in to the overview. Well, prerequisites. What do you need to know in order to get the most out of this course? Well, the first thing is you need to have a good understanding of IPv4 and IPv6 concepts. And then you need to have a basic understanding of OSPF, typically at the CCNA level, although there will be some overlap with some of the topics that we're covering when we go into a deep dive into the CCNP level tasks that are outside the CCNA realm. Definitely a good understanding of OSPF is going to be required, and then simply a desire to master OSPF at the CCNP level. And those are really the goals, is to make sure that when you complete this course, you're ready to go out there and crush any CCNP and CCNA OSPF topics. All right, so let's do a general course overview. Specifically, what are we going to be covering in this course? So we're going to do a brief review of CCNA level OSPF concepts, and that's going to happen as we go through each of the modules in the course. We're going to talk about configuration basics, adjacencies, message types, neighbor states. We're going to look at the DR and the BDR, right? Because this is something that for a lot of learners can become very confusing. Not only why we need a DR and a BDR, but specifically which OSPF network types are going to require us to have the DR/BDR and why we don't have it on other network types. So, and a good segue right into the network types, we're going to be talking about all of the OSPF network types: broadcast, non-broadcast, point-to-point, point-to-multipoint, and then the Cisco special, point-to-multipoint, non-broadcast. Now, one of the pieces of feedback I got is that viewers really enjoyed covering a topic. So in other words, covering adjacencies and then providing troubleshooting scenarios in its own standalone video right after covering the topic. And so we're going to continue that trend throughout this course, where I'm going to go ahead and we're going to cover a topic, and then we're going to talk about the different troubleshooting scenarios that you may run into, right? What happens when the network types don't match? What happens when the adjacency isn't forming? Why would that happen? And so we're going to look into each of those things, and those are going to take place right after we have the discussion on the topic. That way that stuff is, the information is fresh. All right. We're going to talk about the OSPF timers, the link state database, definitely a deep dive into the LSDB, a look at the LSAs, and we're going to be doing all of this for OSPF v2 as well as OSPF v3. IPv6 is starting to play a much larger role, much more prominent role in all of the Cisco, not only learning materials, but throughout a lot of the publications. We're starting to see IPv6 definitely play a more prominent role. We're going to look at layer 3 traffic engineering, definitely multi-area OSPF, autonomous system boundary and border routers, ABRs, area border routers. We're going to be doing summarization at both the ASBR and the ABR, and redistribution. One of the topics that is typically a little more difficult was when we get into redistribution. How do we redistribute from OSPF into other routing protocols, and then vice versa? How do we redistribute from other routing protocols into OSPF, and what's going to be required there? So we'll definitely be talking about the OE1s, I'm sorry, the OE2s and the OE1s and the N1 and the N2 types. All right, we're going to be looking at authentication. We're going to be looking at link local signaling and what that means. In fact, you're going to see that a lot when we do our packet captures, the LLS. We're going to talk about stub router advertisement, right? So max metric router LSA. So how do we transition an OSPF router to sort of behave in a stub fashion, or to basically have it advertise the max metric and then it's routed around. We're going to look at optimization techniques with OSPF, specifically ISPF, or the Incremental Shortest Path First, in addition to bidirectional forwarding detection. And then we're going to take our knowledge of OSPF and we're going to put it into the context of MPLS, right? What role does OSPF play and how does it facilitate the BGP-free core? And then we're going to look at OSPF in a DMVPN setting, right? What are some of the considerations that we need to take into account? And again, the focus here will be on OSPF, not so much on DMVPN. So you won't see single hub, dual hub, different scenarios trying to drive home DMVPN points. We're really going to stay focused on the OSPF semantics. And then RFC 2328, right? This is the most recent RFC that covers the OSPF v2 specification. I stress v2 there because RFC 5340 is the RFC that's going to cover the OSPF v3 specification. And then finally, RFC 5838, which is very important. It's the RFC where it covers the introduction of address families into OSPF. And so your OSPF configuration when you're working with address families will start to mirror the EIGRP named mode a little bit more. There are some significant differences. First and foremost, the OSPF address family mode. When you're running OSPF with address families, remember that it isn't exactly the same as the EIGRP name mode, so there are some differences. And we'll see those throughout the IPv6 configuration of OSPF. We'll look at OSPF in the MPLS L3 VPN PE to CE use case, specifically with the sham links, and we're definitely going to be covering virtual links, right? That virtual link that will allow us to sort of stitch together discontiguous areas that don't have reachability to Area 0, or I should say that don't have an interface in Area 0. And then we've got OSPF area types. We're going to cover the stub, the totally stub, the not-so-stubby, and then the totally not-so-stubby area. OSPF v3 and v3 with address families goes without saying. Those are going to play a huge role. And so I also wanted to provide you with some additional resources. And you can see the slide is filling in. There's a lot going on here. But first and foremost is the book by the author of OSPF, right? The creator of OSPF, John T. Moy. And this is what you'll hear this commonly referred to as the blue book, because there's a yellowish book, and that's probably not the book that you're going to want to look at. That book, the yellowish book, is actually how to write your own implementation of OSPF, whereas the blue book, the book I've got listed here, this is the text that actually goes over the history of OSPF and then into a very deep dive of the protocol. One of the criticisms that you'll hear is that the book is just like the RFC, but I definitely have a different opinion, especially from a historical perspective, because the text goes into the reasoning behind why they decided to go with OSPF as a link state routing protocol, what the driving factors were behind the undertaking of trying to come up with a more scalable, better protocol than RIP, right? And so there's some very, very interesting conversation. In fact, in the book, you'll read that Moy actually admits that OSPF, as soon as you start to do multi-area OSPF, basically becomes sort of a distance vector protocol. And we'll talk about that as we go through different scenarios. So OSPF and ISIS, right? Again, I'll let you make your way through here, but let me highlight the Cisco configuration guides, absolutely fantastic. And I highly recommend that you look at other INE authors, right? There's a lot of different authors who are out there who have some great videos on OSPF as well. And sometimes the way that I'm describing something might not come across as clear as maybe how somebody else is describing it. It might be more in line with the way that you learn. And so again, I refer to that as sort of the iterative approach, right? Is to look at different sources, read different sources, view different authors, and take away everything that you can from that content. All right, you've got your INE All Access Pass as well. And let me tell you right now, I've got this app on every iDevice that I have, and I use it constantly. If you've got a 45-minute commute to work, what a great way to listen to the videos while you're driving in. Don't waste that 45 minutes in and 45 minutes out just driving, right? Take advantage of it. You've got access to everything with your All Access Pass, and you can put that on all of your devices. And then you've got the All Access Pass on your Apple TV. And I love being able to play the videos on my Apple TV. You get to watch Brian McGahan go crazy with Cisco technologies, and it's absolutely fantastic. So again, two great ways to access the content. And again, you get everything that you get with your All Access Pass. You're going to see it all on the TV in terms of the video content. If you're looking, if things start to get a little too quick here and it seems to get a little too deep and you need to go back and review, just a quick plug that I do have a CCNA candidate's guide to OSPF out there, a little over 5 hours of content, and so that basically will cover all of the introductory CCNA level OSPF information that'll help you bridge the gap of knowledge that you might have if things in the CCNP course that we're doing here get a little too complicated. All right, we're also going to see Wireshark. We're going to see a lot of Wireshark output, because really, when you get down to the packet, the packet and frame level, is where you get the really granular details that tell you exactly what's going on